going to continue target 2B today, graphing tangent and reciprocal functions. Today we're going to begin looking at the reciprocal functions, and in particular we're going to look at the graph of cotangent. So just like we did before, we're going to go ahead and explore the values of our parent function with our unit circle, and we're going to be using angles between 0 and pi. So it's important to remember before we start that our tangent function on the coordinate plane, like we saw last time, is equal to y over x. And we know that tangent and cotangent are reciprocal functions. If you remember, that means that cotangent is the reciprocal of tangent, which also means it's going to be the reciprocal of y over x. So cotangent equals x over y. So we're going to use the same context of our ordered pairs on the unit circle and our reference triangles to evaluate cotangent for these given angles. So now that I have all of our angles and sides and coordinates labeled, we can go ahead and evaluate our cotangent function. So the cotangent of 0 radians is going to be x over y, so 1 over 0, and this will get an undefined value. So it looks like our cotangent function is going to have an asymptote similar to our tangent. Our next one, we know cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it will be adjacent over opposite. So 1 over 1. And then we have cotangent of pi over 2. So that will be x over y, 0 over 1, which gets 0. And then cotangent of 3 pi over 4, we know that will be adjacent over opposite, so negative 1 over 1. And then cotangent of pi radians, will be x over y, or negative 1 over 0, which will be another undefined value. So it looks very similar to our tangent function. However, we notice that cotangent is decreasing, not increasing, like our tangent function. We also notice that we are between 0 and pi instead of between negative pi halves and positive pi halves. So there are some similarities, but there are some important differences as well. So let's go ahead and graph our parent function now that we have our 5 key points. So I have our axes labeled. I used one box is equal to pi over 4, and then I have my standard labeling on my y-axis. So the first thing we're going to do is go ahead and draw in our asymptotes. So these are vertical asymptotes again, because we have x values that cannot be evaluated for our function. So we have an asymptote at 0 and at pi. Then we can go ahead and graph our other key points. So pi over 4, 1, pi over 4, 1, and then we have pi halves, 0, and then 3 pi over 4, negative 1. So we can see that it is decreasing, but it has a very similar shape to our tangent function. So this will be one period. We can see that the period is equal to pi. So this is 1 period. So the period is pi, and we can see that our domain is all of our x values except the ones that have asymptotes. So if I go ahead and draw another period, we can kind of see where these asymptotes will keep reoccurring. We can see that the asymptotes will occur every pi units away from 0, pi, 2 pi, 3 pi, and so on. So in this case, the domain are all x values that do not equal any number times the period pi. So we could say our vertical asymptotes would equal any number times the period pi. So we're going to see they occur at pi intervals. And our range, just like our tangent function, is all real numbers. Whoops, all real numbers. So that's between negative infinity and positive infinity. So just like our other tangent functions, we can also transform our cotangent function. And we'll just look at one example, and then you'll be able to try a few on your own. So we're going to work on cosecant and secant functions later. we're just focusing on our cotangent. So just like we did before, we're going to use the same information that we would use to graph our cotangent as we did our tangent. It's just important to note that we are now beginning and ending at different places than our tangent function. So cotangent begins at 0 and it ends at pi. So this would be our start and this would be our end. So we just have to kind of keep track of those different starting and ending values, given we are using now cotangent. And then we also have kind of reversed parent function values. So again, there are some small differences, but it's very similar to graphing a tangent function. So we are graphing -3 cotangent of x minus pi using our 5 key points, and we want to include 2 periods. So we know that our cotangent function, we take whatever is inside the function and we're going to set it equal to where the parent function starts and where the parent function ends. So our cotangent parent function starts at 0 and the cotangent parent function ends at pi. So if we go ahead and find our asymptotes for cotangent, this particular function will begin at pi and it will end at 2 pi. So that means the period will just be 2 pi minus pi, which equals pi units, and the interval will be the period divided by 4, just like before. All right, so all we have to do now is make our table of 5 key points. So we will start at pi and end at 2 pi, and we are increasing by 1/4 pi each time. So we have 1 whole pi plus 1/4 pi. We can think of this as 1 1/4 pi, and then 1 2/4, or 1 1/2, and then 1 3/4, and then we get 2 pi. Again, you can write these as improper fractions. You could also simplify. I am leaving it this way so you can see the structure and where these values are coming from. Again, we add that interval and then we can see how that is increasing by 1/4 every time. Now we're going to use our parent function y values, and we know that those are decreasing, so they're going down. The last step is to multiply by our a value. So we're multiplying by -3. Now we can go ahead and graph our function. So our vertical asymptotes are happening at pi and 2 pi. And we can graph our other key points. So we are going from 1 1/4 pi and then down to -3 pi. And then we have 1 2/4, 1 2 boxes, or 1 1/2, 0. And then 1 3 boxes, or 1 3/4, up 3. So we can see there was definitely a reflection with that negative value. And there's a stretch because these quarter points are no longer 1 unit away. So now we'll graph our second period. So we're going to go 4 boxes over, or pi units. And then use the same values. So again, graphing our cotangent, we use the same process. The only thing that we want to make sure we are using that's different is the ending and starting points for cotangent are 0 and pi, and then our parent function values are decreasing instead of increasing.